I will be going over my assignment presentation titled A Comprehensive Argument for the Disproof of the Bunkbed Conjecture. This is for LST 110, and my lecturer is Miss Yu Funde, um, and it is from the article titled Mathematicians Just Debunked the Bunkbed Conjecture, written by Wired. And this is written by a mathematical statistics student, which is me, and I am Kanumba Ntakisi Makubele, and this is submitted on the 21st of May 2026. This presentation is based on the article titled Mathematicians Just Debunked the Bunkbed Conjecture, published by Quantum magazines and then reprinted by Wired on the 24th of November 2024, and was originally written by Joseph Howlett. This argumentative presentation is for the disproof, as it's not just about a single problem in mathematics, but it highlights that even widely recognized mathematical reasoning can fail, especially when built up from what feels almost obvious. It is therefore important that we use rigorous methods. The article was published on the 24th of November 2024, which is fairly recent, and highlights its relevance in the argumentative presentation, as it explores the importance of applying rigorous mathematical proofs rather than just relying on mathematical reasoning. It was written by Joseph Howlett, and he has a PhD in physics from Columbia University and was previously a postdoctoral researcher at Stanford University before getting his master's degree in science communication at the University of California, Santa Cruz. The article is targeted to people who are interested in recent mathematical developments. This can be math professors, etc. This disproof is credible since it was written by three mathematicians at Columbia University using rigorous mathematical methods to uncover, which ultimately disprove the conjecture which relates to my field of study, which is mathematical statistics, because it relates to probability and the very foundations of mathematical proof writing. Let's just go over a bit of background. The Bankbed conjecture is a statement in percolation theory, which is a branch of mathematics that studies the behavior of connected clusters in a random graph. A recent counterexample by Nikola Gladkov disproves this conjecture. We go on to article analysis. The writer makes the argument that although mathematics may be largely based on intuition, that may keep us from seeing the bigger picture instead of what should always back up what feels obvious with undeniable mathematical rigor. Now let's talk about evidence. Three mathematicians, namely Nikita Gladkov, Igor Pag, and Alexander Zemin, published their counterexample in 2024 using complex mathematical analysis in a long and detailed proof published by the University of California on the 8th of October 2024. They could now they could now use those techniques they realized to adapt Holom's hypergraph. Gladkov, Park, and Zemin replaced each three vertex edge on in the hypergraph with a massive cluster of points and normal edges. This gave them an enormous graph of 7,222 vertices connected by 14,422 edges. They then used the theoretical argument they built up from after abandoning the artificial intelligence approach to prove that in this graph finding an upper path was 1 over 10 to the power of 6,500% more likely than finding a lower one, an unimaginably small number, but a non-zero number nonetheless. The Bankbed conjecture was wrong. Now we move on to my response. Another famous example of disproof of this nature is the Martin's conjecture by Thomas Johann Stieltjes in 1885. It was disproved by Andrew Ordbiscoe and Hermann Riller in 1985. It involved the behavior of the Mobius function in number theory. It was believed to be true due to it working for every tested number. Its disproof is testament to why we should always put ideas under intense mathematical scrutiny. Another interesting disproof is the disproof of the Polya conjecture. The Polya conjecture stated that most, i.e., 50% or more, of the natural numbers less than any given conjecture by George Polya, who theorized this in 1919, but was however disproved. This makes sense intuitively. However, a counterexample showed that maybe mathematical intuition isn't enough. In conclusion, conclusively, the main argument that although most of mathematics is built upon intuition and what makes sense, we should be looking towards mathematical rigor when writing proofs in as much as we may rely heavily on logic. This is highlighted by the numerous amount of proofs that were thought to be obvious but later disproved by counter-examples. Here are my references, of which I found most of the information, especially that which was quoted, as most of this or some of this information, yes, most of it is not my own, but it's taken from these sources, namely Wikipedia, uh, Wired, and the proof of the bunkbed conjecture or the disproof of it. Thank you.